Alright, so this problem says a major league pitcher can throw a baseball in excess of 41 meters per second. If a ball is thrown horizontally at the speed, how much will it drop by the time it reaches a catcher who is 17 meters away from the point of release? So this one is going to go off here at 41. I said earlier I want to avoid negatives as much as I can. It doesn't say in which direction, so I'm going to try to avoid the negative and turn the whole image around. Okay, so here we go. So this one here is 41.0 meters per second. That's about 90 miles an hour. And then it's supposed to go a total length here of 17.0 meters. So about 50, how much is that? 56 feet. 17.0 meters. And then it says it's thrown horizontally. That means that the initial vertical velocity is 0, and then it drops due to gravity. Have you ever wondered why pitchers have to stand on a mound? Well, that's why, because 17 meters or 56 feet, that's an appreciable distance, and if they want to throw horizontally, they might actually throw a little bit up. Then the ball will drop in appreciable distance. In fact, we will come up, or you will calculate that it's just about 3 feet during that distance. So it drops appreciably, and that's why they have to stand on a mount. Anyway, let's see if that is that all the information that's given. Yes, it is. What they're asking for is how much will it drop. So they're actually asking for y, because this is a typical problem in 2 dimensions, so I have to split it up into x and y. Let's see what happens here. What is given? 17.0 meters. All these problems assume no air resistance, so there wouldn't be any acceleration in the x, so this is 0 meters per second squared. Then we have v0x is given as 41.0 meters per second. Because of that 0 here, we also have 41.0 meters per second for Vx anywhere. We don't know what the time is. Let's see, for the Ay we have negative 9.80 meters per second squared given. For the Vy, we have no idea what it's going to be at the end, and we don't need to know it. They're not asking for it. 0 meters per second, and the vertical is the original speed, and we don't know the time. Now, ultimately, we need to know what the y is, but if you look at these here, what is given, and now you look at the equations that are supplied, you can see that, it's not going to work out. We need some more piece of information. We need either Vy or we need t. Well, the t we can get if we determine it up here. So I'm going to put a question mark here, and obviously we have a lot of stuff given here. We can readily determine time, and once we have it, we use it for the y direction. The one up here, one of the ones to use would be 3.5a. In this case, they're actually, because so much information is given, we could actually use another one as well. But this is one here, v0xt plus 1/2 acceleration in the x times time squared. This one here comes out to 0 because the acceleration is 0, and now we can determine what the time is, being it's supposed to be an equal x divided by v0x equals, there we go, so it's 17 divided by 41, so in the neighborhood of 0.4 seconds. Then we take that time that we have determined here, we plug it in here, so we use that number here, the approximately 4.4 seconds, and again we're going to look for an equation where we can find out what the y is. Turns out it's the same equation as the one used above, so 3.5b. I'm going to move this a little up. So y equals v0y times t plus 1/2 ay t squared, with the v0y being 0. and then equals. Now we're going to come up with something. Here, of course, we have negative 9.8. Here we have whatever we determined up here. And notice that we come up with a negative height because the ball drops down. As I said, it's going to be in the neighborhood of 3 feet, respectively. You're going to calculate it in meters.